This conference will now be recorded.
Sir, Vignesh sir, I think we waited for enough time, sir. We can start the session, sir.
Okay, man. Thank you.
Yeah, thank you so much, sir. Sorry for the delay.
Not an issue.
Thank you so much, sir. Please.
Okay. Good morning, everyone. So the topic for this session is Hyperledger Fabric. So we would have spent a series of sessions on knowing about what is blockchain technology, what are the components, how it is being used, and you would have seen different use cases. And you are able to, I hope you should be able to map the use cases in the real world where blockchain is going to be is being used prevalently or is going to be used. Okay, Hyperledger Fabric is one of the offspring of the blockchain technology. So in this session, we are going to look at why this new variant is needed, what business problem it is trying to solve, how the architecture of Hyperledger Fabric looks like, what are the different components involved in it, what does it take to implement in terms of programming language, in terms of technology, what kind of technologies or programming languages are behind this Hyperledger Fabric. And we would end the session with a couple of use cases, especially with respect to e-governance domain. Okay, so it has got the potential of Hyperledger Fabric is promising, and it can solve a lot of problems which rely on digital transactions. Thank you. So we have blockchain and other technologies. We have Ethereum-based implementation. We have one of the prominent implementation based on blockchain technology or distributed ledger is Bitcoin. It's been accepted in India, and people are started using Bitcoin. But why do we need some other new terminology or new other technique called Fabric? Okay. So what's the problem that it is trying to solve? So typically, the purpose of blockchain or distributed ledger is to have the scalable distributed transaction among the business entities. Okay, so if you just have a look at this diagram, so we have different business entities are being part of a particular transaction. So there is a company called A, and there is a company called B, and if they involve any financial transaction, then there has to be a bank. Also, they should have some insurance company, and there must be some regulatory, so that they're going to monitor and they're going to regulate it. And finally, they should be audited. Okay. So basically, when we say transaction, so it's just it all boils down to data, right? If I am going to make a transaction with so A is going to make a transaction with B, and that has to be monitored by a bank. Okay, so the moment I transact or A transact something or some asset, transfer some asset to B, then that data is shared between A and B. But somebody has to authorize it, right? So somebody has to be watching it from the regulatory perspective, and so the transaction has to get reflected in the bank, because just like things cannot happen, and everything should be governed by the law and all the associated regulations, right? So the same data will have to be validated by auditor for bookkeeping purposes. So this model of solving the problem is inefficient, or it is not scalable, and more, it is vulnerable. So why do we say it is vulnerable? So the blockchain is open, right? So there is no such restriction. So anybody can join the network, and they can become part of the network, and they can do transactions, right? It is just like internet. So anyone can be part of the network and do network activity. So this is, I would say, blockchain is something similar to a network. Okay, what is then Hyperledger Fabric? Okay, quick answer is going to be we have our own VPN, right? So you might have come from different academic institutes. Every institute might try to, or every organization might try to have a VPN, virtual private networks, that is local or private to their networks, so which is a kind of protected environment. Which is a kind of protected environment from the internet. So even though that is going to run along with the internet, but that's kind of that is specific dedicated to this company alone. Okay, so likewise, blockchain versus Hyperledger Fabric. So as in case of if you try to solve this kind of problem, say for example, this is not a this particular. Okay, so few companies might be interested in doing businesses among themselves and making transactions among themselves. And if that is the case, then all the transactions will have to be secure, and only the interested parties to be allowed to take part in the transaction. So not if two big companies are about to make a transaction, so it must be closed or it must be private to them. Okay, it should be exposed to those two companies and some regulatory authorities or maybe some bank or government agencies, right? So how to achieve or how to have that? So Hyperledger Fabric is the answer. So because of the issues found, or we won't say this is the issues because of the nature. So the blockchain or distributed ledger is just designed to have a scalable, distributable environment where data is distributed, and so that's the approach for decentralizing the informations. Okay, but that's good for on some sense. But when it comes to vulnerability, when it comes to secure environment, so we can't bank on, we can't rely on that architecture. So now we should have a new architecture where all these issues are addressed. So what's then Hyperledger Fabric? Okay, it is again similar to the blockchain. So why do we say it is similar to blockchain? It is shared as the blockchain, and it is replicated. And how the contrasting feature is permission ledger. So why do we say it is permission ledger? So it is just you can't know, everyone cannot have access to the ledger, right? It is tailor-made, or it is curtailed so that only the specific parties, only the interested agencies or the institutes can only have access to the ledger and the data. So how are we, what else it is having to achieve this? So with consensus, say for example, we say that the data is going to be distributed, the data is decentralized. Okay, assume a financial transaction that nowadays we are making. So everything is getting recorded in a bank, right? So you may have some account with bank A, okay, but you may withdraw your money from bank B, right? But somehow, how are the information is getting reconciled at the end of the day? Okay, so all the information have to be reconciled between bank A and bank B. A few days back, if you're going to, after a few days, you are going to make some transaction at bank C, or if you're going to make any other transaction through your online portal, the information is finally how to reach the respective bank where you want some account. But in case of blockchain, so the transaction, the data is going to be distributed, the data is going to be decentralized, but there must be some consensus. Why do we need consensus? To ensure the integrity of data, right? So this is what is the final update, or this is the value after the transaction. How do we ensure that? So we are going to make use of, or the Hyperledger Fabric is going to make use of certain consensus algorithm and prevents. So whatever has happened, so you can prove. So when there is any dispute, you should have a trail of transaction, a log of transaction, so that you should be able to prove this is what has happened, right? Times you would have faced this. Now you could have gone to ATMs and you could have swiped your card for some amount of money, but the machine would not have dispatched. When you go for a kind of dispute with the bank, So they are about to check the happening with the logs. So when did you swipe put your card, and whether the money is dispatched or not. Okay, and they physically verify it with the help of the cam and all. So we are here. What I'm trying to say is like that the transactions that are happening in the network, is to be proven. Okay, all the transactions and authenticity of the transaction have to be proved, and immutability, right? So that's another crucial feature of this new architecture. So what do we mean by immutability? The data should not be changeable. Okay. So then how I can update the data, right? If the data cannot be changed, how I can update the data? On top of the existing data, you just add another, right? Say for example, I made a transaction, say that the amount equals 100. Okay, next time I'm going to make some transaction. So don't erase the data 100. Instead, let the transaction 1 happened at day 1 at say 10th hour. The transaction amount is 100. When I'm going to make another transaction, so on the same day, you say that day 1, say at about the 12th hour, the transaction worth is say 120. So like that, we keep everything on top of it. So we're going to append it. So we're not going to be erase the data. Try to compare this with your so most of the people could have seen in the shops, they keep a ledger, right? Whenever they get any business, or whenever they do any transaction, they don't overwrite the previous transaction, right? So they just put time, say date, and maybe the person with whom they're making transaction, and they just make the entry in the other line. The original data remains immutable. Original data remains unchanged. On top of it, they're going to be adding more values. So here, how does it look like? So how does it look like? So this is again similar to blockchain, but so this is a permission ledger. So this is a local or private ledger which is being exclusive to the participating agencies. Here A and B are the participating agencies, but others are from the compliance perspective, like the auditor, the regulator, or the insurer have to come from the regulator, from the compliance perspective, whereas the bank is the medium which facilitates the transaction to take place. So it's a kind of closed environment so that all the transactions can be seen, can be accessed only by these set of entities. No one else can be part of this network, and the security or the data consistency is ensured. So where do we need such use cases? Say for example, there is a business, there is a diamond business. So the use case is like how to track diamonds across supply chain from mine to retail. We all know how the diamonds are being, is being made, right? So they just go deep into the mine and they get the raw and they just process it, right? So this is the use case. But do you think there is going to be only one entity or only one business will be involving in this? No. So will all the activities pertain to this have happened only one geolocation? No. Okay. So the mine may be situated in some part of the world, and the company which is going to process it might be in a different location of the world. The company is going to export it. The shops where they are being sold, so they'll be in a different locations. So what I'm trying to say here is there are a number of such participating agencies. Okay, so how are we going to maintain the data transaction among all participating agencies? So using how this is going to be achieved using shared ledger for storing digital certification with supporting material. So we all know what is a digital certificate, and using a digital certificate in the space of network or in the space of internet, we are going to get authenticated ourselves, right? So this is something like your ID card, right? So whenever some students or some staff go to a specific place or college or university, so they just show their ID card, right? So we have other the identity card, right? So what are we trying to say? So that is going to say who am I? Okay, this is what I am, and I study here, I work here, right? So with that, we are trying to identify ourselves. So likewise, in the space of network internet, we have something called a digital certificate, which is going to uniquely identify us. So all the participating agencies or entities or organizations will have these digital certificates, right? So every year we file our tax, income and returns, right? So there are a couple of options available, whereas the larger enterprises, they submit it online using their digital certificate. Okay, so the digital certificate will have two keys. Okay, right. So if you're from the computer science stream, then you must be aware of all this, right? So private key and a public key. So the private key is private to you, whereas the using the public key, others can recognize your messages, and they can get the details that you've signed. Okay, so what are the benefits if we apply this kind of Hyperledger for kind of the business like Diamond? What benefits it is going to get? So it is going to protect against occurrence of fraud, theft, traffic, or block markets. Okay, so how are we going to ensure it? So we will be looking at how to construct a Hyperledger fabric network, how to allow the participating entities, and how are we going to track each and every transaction that they're going to make. Okay. The second benefit is so the overall business process management, right? It assists identification, detection of synthetic stones being labeled as authentic. Okay, so there may be some malfunctions, so they may be doing some activities which might which might term the synthetic stones, right? So that can be avoided. The third important benefit is like transparency. Okay, so whatever transaction that is going to happen on the network is transparent. All the participating organizations can easily verify what has happened, when it has happened, right? So try to compare this is a scenario. So you can replace participant A and B with, say, miner and retailer, whereas the others are going to remain the same, bank and auditor and all, right? At any point of time, the bank can verify or the auditor can verify what has happened, when it has happened, what is the kind of transactions, right? So all the participating institutes can verify it. So it is going to provide some transparency, right? So this Hyperledger fabric is one of the promising, or the blockchain per se is one of the promising techniques. Most of the e-governance projects can see a lot of use cases. Maybe so we see a lot of smart city projects coming up. So how this blockchain and Hyperledger fabric is going to play a vital role. And nowadays, we are locked. We live in this lockdown, and this lockdown has changed the way the education system has been working so far. So we attend classes remotely, and sooner the days will come where the examinations are going to be conducted, like this. So virtually, right? The students may be asked to sit at their homes and they may write some examinations. But so blockchain or the Hyperledger fabric can be one such technology where the answer papers can be uploaded, and it can be validated. It can be shared, accessed between the interested parties. So see, only between few departments, or only within the college, or only between the faculty and the students, the paper can be uploaded, and you can verify, validate it, and it is there. It is decentralized. So there are a couple of interesting use cases using this blockchain and Hyperledger fabric can be applied. This is another use case. So before we get into the technical details of Hyperledger fabric, so we have started with what is the problem with the existing Hyperledger blockchain technologies, especially with respect to security and vulnerability, and how it is being overcome. So using permission or private blockchain network. Okay, so what are the different use cases? Is what we are looking at. Next, we'll get into technical details of the Hyperledger fabric. So what is foot trust? So we know that foot, is FPMG is a significant segment in the world, and there are a lot of companies being taking part in that. So what is the requirement? So trusted source of information and traceability to improve transparency and efficiency. So having the food network. So not a single player can cater to all food requirements. There are a number of such participating agencies. So the big companies who are participating in the names, the logos are there, right? So if that is the scenario, then how to ensure traceability, and how to improve transparency and efficiency. So efficiency is very generic, and efficiency has got multiple things. So how to reduce time in which you can sort of right from the procurement till the retail, if there is a gap, how we can improve it, and how we can be performing better in terms of time. And how to achieve this, as with the earlier use case, so the shared ledger is going to help us with the help of digital certificates and audit certificates. So what is the benefit it is going to offer? Yeah, here in this particular use case, so this has reduced number of food recalls. Okay, so we all know that so for every food item or every consumer has got some warranty period, right? So even when we go and get something from the shop, the first thing that we check is when is the date by which it should be used. The moment we say that the date of use has got is passed, then we would just return it, right? So that is what is called food recall. So the more such recalls are happen, so it is going to affect the retailer. It is not going to affect the retailer. It is going to affect the distributor and back to the manufacturer. So here is a chain how it happens. Like there is a farm where the things are getting the shit is getting produced, and there is somebody called as processor, and there is somebody called as distributor, and finally it reaches the retailer, and with the retailer we are going to check it, right? So this chain in which so the consumables produced at the farm, this is how it reaches this, it passes through this chain, and finally with the retailer we are going to consume it, right? So how to reduce the impact of food recalls, how to minimize the delay between each and every nodal point. Okay. So this is one of the use case in the food segment or FP&G segment. This is another use case, cross-border supply chain. I'll just to take you through the benefits. So again here it has increased the transparency by employing Hyperledger fabric. So it has paved way for transparency, and it has just reduced fraud and errors, and reduced time products. Okay, so this has resulted in the industry of saving billions of dollars. And the implementation is going to be the same. So we'll have to identify the participating agencies and build a network and authorize it. And we all know how a typical non-digital world works, right? So you'll have to. We all know that we would have come through the stages, right? If since everything is digitized, there is no waiting period. As and when we make any application, we make any submission, it reaches the next nodal point, and it is just the time they spent on validating or verifying it, and it has got greater impact on reducing and getting things done at the earliest. Now is the time to formally understand or formally define what is Hyperledger fabric. Okay. So this is a foundation for developing blockchain applications for the enterprise. Again, this relies on blockchain. So you could have seen what is blockchain and how things are done, and what is distributed ledger, and what is decentralized way of storing data, and what benefit it offers, and how it is being used in different institutes in India as well as across the world. But it's a deviation or offspring of the blockchain technology, in which it is trying to contrast itself, or it is trying to differentiate itself in the following aspects. The first and the foremost, as a crucial fact by which it differentiates itself from the blockchain world is it is permission. Okay, whereas blockchain is open. Okay, so permissions, I hope that everyone should be able to relate or understand what does it mean, right? So it is just a subset of the entire blockchain network, and it is private to a certain group of entities. And it is performance oriented because that is so we have limited the scope of the network. We have limited the scope of the number of participating agencies, and even among the participating agencies, we're going to have some endorsement policy, and we're going to have some security, who can do what, who cannot do what. So all that access control is enforced, and that is going to be in place. And it is going to be performance oriented because the network is very limited. It is not exposed to all. And another important feature, as important will be the first feature. First feature is permission, whereas this one, smart contracts. So what do I mean with smart contract? So we have data, we have distributed it, and the decentralized ledgers are there across the world, and so ledgers are the place where we have stored data, right? But when it comes to transaction, the transaction cannot be a generic one, right? Today we would say transaction A, where so when we say transaction, the transaction could be anything. So the transaction could be for a tangible thing. Say, just refer to this couple of use cases here. The asset is diamond, so diamond is being transacted, or diamond is the unit of business. Whereas in case of the second use case, it can be anything. So it involves so many parties: farm, processor, distributor, and retailer. Okay, again, it can be any consumable product. Whereas in case of this one, this is a fleet and cargoes, right? The asset can be anything, like it could be hardware, software, or a Bitcoin, anything. But when we are going to perform any transaction, okay, so the transaction is nothing but we have data distributed. What is data? Data about assets. Okay, this is the asset. This is the quantity I own, right? And the smart contract is nothing but business logic. How to define a transaction? Okay, should I add this much of dollars, this much of amount to meet this transaction? Okay, so we should define business logic, right? So smart contract is nothing but business logic. Otherwise it is called as chain code. So the code is going to execute across the chain of distributed ledger. So we have different ledgers distributor, and they're just connected. If you're trying to visualize it, that is going to look like a chain, right? So across the chain, wherever the data resides, you would need some business logic to be executed. Okay, it is not going to be party A and party B. Okay, so if I try to recollect, try to associate with this diagram. So even though there is a transaction happening between party A and party B, but bank is a facilitator. His records to be updated. Okay, an auditor. Anyway, he's the one who is going to be at the end of the year or at the end of the quarter is going to audit it and validate it. And even these two parties, like insurer and regulator, they are interested in the transaction. So they want to they want always to ensure that it's legitimate. Okay, though the transaction is between party A and party B, so all other parties are interested and the data should be available. Okay, so how to ensure it? So each and every ledger or every node where the data resides about party A and party B is going to be inserted with a smart contract. So it is rightly said. Why don't we call it as a business logic? Rather, we prefer a smart contract. So the code is smart enough that it's going to execute across the ledgers, but there is a contract. So the code cannot be executed just like that. So the code gets executed based on some contract. Okay, so what is a contract? Who's between whom the contract is going to be? Between the parties who are going to make the transaction. So they'll come to an agreement, and based on the agreement, the smart contract or the chain code is released, and that is going to execute along the chain of the network. Okay. And it is highly modular, and it also provide options for pluggable consensus, ledger, membership services, endorsement, and validation. Right? These are all crucial factors when the data is decentralized. We would need some endorsement authority, and we would have some mechanism to validate whether the transaction is perfect or is it okay to have, or is it to be performed again. And we should we should limit access to the network by providing members. There is something called as MSP, membership service provider, who is going to do that. This is something like your network admin, who is going to basically allow overall can have access to the university network or college network. And applicable consensus. This is another critical protocol. So consensus is needed when we have different participating nodes and the data is distributed, and and we want to ensure the transaction has maintained integrity of data. So to ensure that, we would need consensus. So for rest of the discussion, this is how we are going to look at. So we'll be quickly going through the problem statement and why part of the blockchain. And so the next major section will be Hyperledger Fabric architecture and few internals. So Fabric internals, we'll be looking at it. And finally, we'll try to compare this with the other implementations and certain other use cases we'll be looking at. So this is what we have defined and what is the problem with the existing approach. This is expensive, vulnerable, inefficient. From this is what we are trying to reach, so that there is consensus, the data is immutable, the data is not tampered, and it is going to be appended. Whatever transactions we do, it is going to be appended over and above, and it is provable, and data can be verified for its finality. Okay. So what is the business requirement? If you just take any business, okay, so you run a company, you are the you are the producer of certain consumable. There is going to be another party who is going to get it from you, process it, and they're going to sell it in the retail market. Okay, if you two are going to interact with each other, what are basically you would expect? You would basically expect privacy. So how do we say privacy? So whatever transaction that you two are going to have, it should be secure, authenticated, and access controls are enabled. Right. So nowadays we perform a lot of online transactions, right? Or using your account, only you can do the transactions. How are we ensuring it? You have username and password. You're being sent. You're being sent with OTP. So you'll be sent, OTP to validate your transaction. I could hear some background noise. Okay. The second requirement is trust. Maybe there is some background noise. Can you please? Fine. The other big business requirement is trust. So all the transactions are verified and endorsed by trusted relevant parties. Okay. So when we make any transaction, so in the world of online banking, who is trying to establish trust? If you are going to make any online transaction with someone else, so that is controlled by bank. If there is going to be any dispute, the bank would pitch in. Okay. If there is going to be disputes between two different banks, there is some regulatory body who governs all banks. All right. So we have a trust authority. Okay. So it is not just, even though it operates in a decentralized manner, but there is somebody is being heavily relied upon to ensure this trust. Or we expect if any business is there, then we should have somebody to rely upon for trust. The third business requirement is shared ledger. So here in this particular slide, we are trying to understand what are the typical business requirements and how Hyperledger Fabric is trying to answer all this, or trying to meet all these business requirements. Third thing is shared ledger. Okay, in the days past, all the transactions and all the day in day out transactions, and the people used to record it on a paper-based notebooks called ledgers, right? If somebody wants to go through, if some auditor wants to verify that, and the books are being circulated, and they just go through all the transaction and verify it. You could have seen that's how the older the days past the auditors would be doing. But now, because of this technologies like blockchain or computer networks. So we have a digital ledgers. So that digital ledger should be shareable. Okay, the moment we are going to share the digital ledger, it should not be tampered. Whatever we have in the ledger should not be tampered. So how do we ensure it? Okay, so we are going to have some feature called a data immutability. So whatever data is there in the ledger, okay, it cannot be changed at all. As I told earlier, the data cannot be changed or should not be changed. That's one of the business requirements. What will happen if you tamper the data or if you overwrite the data? So so that is going to dilute the essence of the transaction. What has happened is lost. Okay, when it has happened, between whom it has happened, all the granular details of the transaction is lost. So that's why one of the critical parameter is, so don't allow any data to be changed. If at all, if anything you want to see an update, you just append it. That's why it is called as append only mutable. Okay, so it cannot be changed, but if for some reason you want to see newer values, newer additions or modifications, anything you want to see on the data, you just append on top of it so that you can see the trail. On day 1 this was the value, on day 2 this was the value, on day 3 this was the value. There were 3 or 4 transactions happened, and this is how the changes have happened. So try to compare it with the typical paper-based ledgers in the days past we have used to. And that should be shareable across the business network. This is another critical business requirement. It should be shared, but not to everyone, only to the business network, right? So we have some private network. You must be having some network in your college or file system, file sharing service that is only exposed or only available for your college, not for everyone. The fourth requirement is smart contract. So smart contract is nothing but business logic or the program. I will bluntly, if we want to define, so that can be a software code that is going to execute, that is going to operate, that is going to run on top of your code to make changes to reflect some transactions. So the business requires certain smart contracts to be allowed, so that without smart contract you can't change the data. If you are not going to change the data, then you can't endorse, you can't allow any transactions to take place. If there are 2 entities, if they are making a transaction, say for example, I'm going to ship 10 diamonds from my asset to your asset, that's a transaction. Then my transaction, diamond count should go down by 10, and yours count should go high by up. Go high by 10, right? For 10 diamonds, I'll be charging you say $1,000. Okay, so from your account, so that gets reduced by $1,000, and that is managed by some bank. Bank would get some transaction fee, and finally it should reach me. Okay, so how to facilitate it for this transaction? So I and you will sit together and we'll define a smart contract, and we'll define some piece of code, and we'll enter into a contract, and we will execute it at the nodes. What are the nodes? What are the ledgers where it is going to be executed? In my ledger, it will be executed. On your ledger, it is going to be executed. On the bank's ledger, it is going to be executed. So what are the properties of distributed ledger? So I hope you would have seen this in the class past. So it is decentralized, replicated across many participants. Each of them is tasked with, each of them is responsible for maintaining it. And information is append only, immutable. Okay, so if anything is to be changed, you just have them at the end. Immutability makes it simple to determine the provenance of information, right? So if there is no immutability of data, say for example, in the last 10 days, there took place 50 transactions. If 50 transactions, if there is no trail, there is no transaction log, we would lose in the finer details of what was the first transaction, between whom it had happened, when it had happened, right? From which server has logged in. All those details are lost. We're going to have only one number that doesn't serve any purpose. Okay, so immutability is what is going to that's a mechanism by which you're going to prove all your transactions over a period of 10 days. That had happened 50 transactions. With the help of this immutability feature, you're going to prove. So transaction 1 on day 1, this is what had happened. Likewise, it goes on up to for 50th transaction. These systems make it call as systems of proof. So why do we call it a systems of proof? You can prove anything which had took place in the past. Okay, so nothing can't be nothing can't be ruled out in the sense like you can't so somebody can't simply be play around with the system. Somebody can't simply be tamper the data and easily can get away. So how basically does it differ from Bitcoin? So Bitcoin is basically work on the principle of anonymity. So you could have come across the news like there is some ransomware attack. So basically the hackers who do ransomware attack or who do cyber attacks, usually they give their Bitcoin address and they will ask you they will ask the victim to transfer some amount of dollars. Okay, there is some attack called ransomware attack by which they encrypt all the data and at the database or at the file which is encrypted, they just leave a plain text message saying that your data is encrypted. If at all we want a key to decrypt it, you just transfer this much amount of this much of dollars to my Bitcoin address. But with a Bitcoin address, it is very hard to trace to whom that address is belonging. But whereas in case of Hyperledger Fabric, it provides identity who has done it. Okay, and selective endorsement, whereas that's not there in Bitcoin. So Bitcoin is mainly for cryptocurrency, but whereas Hyperledger Fabric can be for any asset. Okay, that asset can be anything. It can be a tangible thing or so things that are visible. Okay, and it can be software, hardware, buildings, maybe fleet, food, grain, whatever it can that you can imagine under asset can be handled by Hyperledger Fabric. Other key features of Hyperledger Fabric is identity management. So it is private and permission based. There is somebody called as membership service provider, something like your lab admin or college admin, who basically allows who can log into the college or university network. And ledger data can be stored in multiple format. Consensus mechanisms can be selective. So if at all, because in each of the consensus mechanism, there is something called as deterministic consensus algorithm and probabilistic consensus algorithm. And most probably when it comes to Hyperledger Fabric, we use deterministic Hyperledger deterministic consensus algorithm because the accuracy of data is very high, whereas in case of probabilistic, that's based on probabilistic, you can't have a high accuracy, even though that is faster, but you can't have accuracy. So when it comes to domains like financial transactions, it is better to have deterministic consensus algorithm. And other key feature is ability to create channel. What is a channel? Channel is a medium which connects two parties who are interested to communicate, who wanted to make some transactions. So Hyperledger Fabric provides an option by which the channels can be created and configured. The channels again, so let me quickly go through the slide. So the channels can be again a private channel, and each channel each channel can the participating agencies can define the channel for their transaction or communication, and it can be controlled. And the chain code functionality is the business logic that is going to operate on the on the ledger where the data is stored. Okay, so for this kind of problems and blockchain found in Bitcoin or the older the other version of blockchain, and Hyperledger Fabric offers solution in terms of consensus, in terms of provenance, and in terms of immutability, and in terms of finality. So single source of truth. So if you just look at if you want to know the truth, and it can be easily inferred. Let's quickly go through the Fabric architecture. So this is how typical Fabric architecture look like. So let's start from peers. So let's begin from this area, Hyperledger Fabric Network, and we have some basic stuff called a ledger, is where we store data, and we have chain codes that is going to operate on this ledger, and we are going to have different events. Okay, so to manage all this, to define transactions based on this ledger chain code, so we have endorser and we have committer. So these are all these two come under peer nodes. So any business transaction that are to be defined or that are supposed to take place is controlled by this peers, participating peers, and they have access, and they let access to their ledgers and chain codes. And there is an admin who is going to oversee all this. And for this fabric, we're going to have a fabric CA, okay, certifying authority. And to get into this this network, so this blue outline defines a network, right? So there is going to be a MSP provider. So to get into this network, the entire network, so we have a MSP provider. Okay. So again, that MSP provider internal depends on external CA. This is something similar to your digital certification hierarchy, right? So take for example, you just take your ID card. Okay, so that carries your name and who you are, your designation, your address, and everything. But at the end, bottom, there is something called as authority. Right? If you are from a college and the principal is the authority, what does it mean? You can find the signature of the principal, right? So what does it mean? The principal is authorizing you are so and so, and you work as professor, or you work as you study there. Okay, so the professor is authorizing it. So somebody looking at the card, okay, so they might see your details, but how do they believe? What does it mean by which they're going to believe it? So they see there is somebody endorsing the information provided printed on the ID card, right? You just for that matter, if you just take any ID card, that is going to be there. In the digital world, if I'm going to say that I'm party, I'm institute A, B, C, or and so there must be some external certifying authority to endorse it, right? So we have derived this concept from the typical cyber world or networking world. And there is something called as ordering service. Okay, so here the participating agencies or the participating institutes basically define these orders. The orders can be distributed, can work on multiple ledgers, but the agencies or the institutes which are interested in doing a transaction, so they basically define this ordering service, right? And this is the client. This is the client application, Hyperledger Fabric client. There is going to be some SDK. We'll be looking at what are the programming languages can be used for this. So using this Hyperledger Fabric client API, so we'll be so that gives what is SDK, software development kit, that is going to help us develop client application or software programs, so that using which first will perform endorsement, and we will perform order, then the order gets validated. Okay, this is a simple view of how a Hyperledger Fabric architecture look like. So to reiterate, so this is the peer node, how the peer node is defined. So we have an entity called endorser and committer, and so they basically operate on ledgers and chain codes and events. For this network, we have an admin, and to certify the digital transactions, we have Fabric CA and some external CA. And to provide access, to ensure access to the network, we have MSP, membership service provider. Okay, and all the participating agencies are jointly defining this ordering service. Okay, to interact with this Hyperledger Fabric network, or to execute or to make transactions, we would need a piece of code to be written, software to be written. Okay, so for that, SDKs are the one which are to be used, using which we build something called as Hyperledger Fabric clients. Right. So this is what we have seen, see our architecture, but how a typical transaction, how does the application interact with the ledger? Okay. So the first thing is like the client application is using HFC, Hyperledger Fabric client, and the next thing is like the smart contract is implemented using chain code. Okay, you managing the world state. So what do you mean by world state? So world state represents to the state of the data, the current state of the data. So this is going to be a database where the current state is being maintained. So the blockchain developer comes and develops a client code application using the SDK, and they also develop smart contract, and they just submit this to the peer node. Okay, so the smart contract, how it is expressed, it can be recording some transaction, or it would be updating the state of the data into the world state, and it can read data. Either it can record or update, it can update the world state, and it can access the data and send to the client application. Okay, based on the context. Say for example, I'm just interested how many quantities, like I'm the diamond exporter, you are the retailer, you would be just interested. Usually if there is no such mechanism, you would just dial to me, you'll just call me, hey, how many diamonds do you own in your store, maybe in your processing unit. Then I may have to go and check and maybe updating it. But rather just forget about all this, somebody is calling you, but rather assume a scenario where I expose my data, it is there on the Hyperledger Fabric network, so that your software is going to directly access my data. Okay, so your software application is going to read my data. Okay, so that is going to check whether do I have enough quantity in store or not, right? And if you need something to be ordered, then you would use any of these mechanisms. You would just based on the prior smart contracts, you would be transacting few diamonds from my account to your account, and you would be transacting a certain amount, and the state is going to be updated. How a typical Fabric ledger looks like. Okay. So ledger is nothing but it is similar to the blockchain. So chain of blocks, and they are connected, and all the transactions are recorded. The very first block is called as Genesis block, and it just contains world state, where the current state is maintained. So the world state database can be implemented using there is something called as level DB, which is a software component which can be used, or there is something called as couch DB. So these all come under something called as, you would have come across this term, right? NoSQL. So these databases do come under NoSQL, and can be used to implement this. And the smart contract decides what is to be returned into this world state. So if we try to understand the larger picture, we'll include more components of the ecosystem. So we'll try to include more users. Like one user is our one ecosystem component is CA, certifying authority. So basically, what do they do? So they just govern or manage registration of identities. They manage certificates. So certificate is a digital certificate, so that is going to define who you are and how long the identity is valid. Right, whenever some student joins a college for UG program, he's given an identity card, and the principal is going to sign and authorize him, and it is going to have validity, say 2020 to 2024. Okay, so every digital certificate has got some validity. You might have come across this when you just visit some website. You can have access to the digital certificate in the address bar by just clicking on the in an icon left to the URL. So there I can see what is a digital certificate, how long the certificate is valid, what is the algorithm that has been used for that. So who is a peer? Peer is the one who endorses or simulates the transaction, commits a transaction using SDK. Orderer is the one whose responsibility is to verify consensus or create blocks. So all these components can be clustered for scalability, and this is another important feature to avoid single point of failure. So this, what do we mean by a single point of failure? This can be simple, we can easily correlate this to our day-to-day business. Like, we have a HOD of a department, and you can't expect the HOD to be available always. At times, he may go on leave, or he may go on for other for official purposes. He may not be available at the station. So in that scenarios, we have some standby, some person who would perform the role of HOD, right? So if there is no such one, if you're going to rely completely on one person, that is what a single point of failure. So even when it comes to software development or the software architecture, we always try to have, we always try to avoid this problem. We always try to solve this problem, single point of failure. So what does it mean? Have some redundancy, have some redundant service in the place of, along with the principal service. So what is a ledger? Ledger is the chain of blocks, and it maintains the world state. And channels, it's just like in a private subnet. Okay, so we have internet, but we, as I told earlier, we have private subnet, which is exposed or which is accessible only for a set of people. And smart contract is nothing but business logic. I told, and it could be like create a new asset, query all assets. This is here the asset is car. Okay, it can be generalized. It can put asset in the place of car, create asset, query all assets, query particular asset property. Okay, like that you can go on. Asset can be anything that is valuable for the organization. Okay, that differs from business to business, context to context. In case of food industry, that is going to be the food. In case of the diamond industry, that is going to be diamond, right? So we ensure the healthy state of peers by having different protocols, whether all the participating agents are up and active. So this is a typical way how this is getting implemented. So these are all participating agencies. Okay, so it's a typical enterprise, how a typical Hyperledger Fabric enterprise look like. Let's assume there are 4 different parties: customer, merchant, bank, and insurer. Okay. So peer is the one. So what do we see? Peer is the one who endorses transactions, who simulates, commits the transactions. Okay. So how those services are being expressed using some RESTful services. Okay. So we use certain programming languages like Go, Java, JavaScript, and here it performs 2 roles: endorser and committer, and he implements chain code. Right. There is some entity called orderer, who's going to verify consensus verification and creates block. And as we have seen, CA is going to endorse the registration and certification management. So this is how a typical implementation looks like. An elaborated view of the previous diagram, more elaborated view how the Microsoft, how are we going to make use of monolithic versus microservice architecture. Right. So here this is an example for monolithic. What you see on the left hand is the traditional monolithic application. So where everything is tied together. Whether the UI, your business can have a number of services. This is microservice 1. This is microservice 2. Okay. This is microservice 3. So the difference is each of the microservice is having this set of its own set of software components. Say for example, in this particular microservice here, it just relies on Redis, and whereas here it relies on MongoDB. Here the data is different. Okay, so why do we have different types of databases? Because the context, the application is different, the data model is different. So that's why we have different microservices. Whereas in case of monolithic, so we are trying to have one single database and we are trying to fit everything. But because of the changes in the computing world, we have so many technologies, right, coming up, IoT, and we have big data. We have structured, unstructured data. You can't fit all data into a single database. So that's why we to cater them in a seamless way. So it is better to have. This is the trend as of now. So we heavily rely on microservice architecture. So we were trying to identify smaller business requirements, and we are trying to containerize them. So it has got much broader benefits. We just put them in a container, and we put it on the cloud, and it is off the shelf. It is going to ensure availability and scalability. So these are the two different implementation approaches. Either the older approach is monolithic, but nowadays we are trying to move away from monolithic to microservices. So the big requirement of the big applications broken into smaller thing called as microservices, and each of them can be scaled up, scaled down based on the demand. So this is what we have seen. So the ledger is a sequential, tamper-resistant record of all state transactions. This is how the blockchain is going to, the ledger is going to look like. There is one ledger per channel. So channel is the medium which is going to connect two different parties. So these are the three components we have seen. Who is a certifying authority and who is a peer. A peer is the one who can update, query the ledger, and who can endorse a transaction, who can authorize the transaction. Manages, he is the one who manages the ledger. The peer has got two roles: endorser and a committer. So here the commit doesn't happen on the fly before something. So what do you mean by commit? So we are going to update the data. So when we say transaction will try to update the data, but when there is some transaction, just after the transaction, we are not going to update the data. We are going to subject the data to something called as orderer, and orderer is going to validate the transaction, and after the orderer, the data is going to be updated. So here it just it is just rightly named. It just provides order of transaction. So how are we ensuring single point of failure? We have multiple instances. We have load balancers and we have HA proxy. And if you come from a typical computer architecture or software architecture perspective, and these are the terms you would often come across. HA proxy is the proxy, and we have a kind of load balancer to ensure HA. So what are the other features that are supposed to be performed by peer? Peer is responsible for drafting endorsement policy. So we'll have some example for what is an endorsement policy. So peers can have multiple channels. Peer just queries the ledger, and so it can read data from the state database. So this is an example how we can have access to the peer command line interface. So if you're familiar with Docker, so easily you can spawn a peer CLI by just running this command. So there are three phases in the consensus. So when it comes to any transaction, right? So there is the first stage is like endorsement, then ordering, then validation. So we'll see them in a bit detailed manner. So we have seen what is an asset and what is a chain code. Yes. So what is an endorsement policy? Okay. So endorsement policy is a one, so using which the peers decide if the transaction is properly endorsed or authorized. Okay. And so peer invokes validation system chain code, and using which all the transactions are validated or verified. So when doing this, it just identifies some signature. So if party A and party B, they are cooperating with each other, whether they are taking part in some transaction. So the signature is basically verified. And these are the few examples how this endorsement basically takes place using CLI. So here organization.member1 and member2. So using this speech. They are validating this endorsement is valid or not. So next we're going to look at, so here endorsement is the will be able to correlate what is the significance of endorsement when we are going to look at some a real-time transaction. Okay, here the basic idea is there are a number of participating agencies. First of all, they have to be authorized. So how to do that? That is what is all defined by endorsement scheme. So why do we need a channel, right? So even though the Hyperledger fabric is a private network, or it is a partitioned, or it is a subset to the set of exposed only to a set of business entities, but within that network only, say for example, party A and party B might want to communicate. So they want that transaction not to be exposed. Why that is the case? Because others may be the competitors. Say for example, you are selling some oil. Okay, there are five leading companies have formed a Hyperledger fabric network. Okay, if company one and company two wants to make some transaction or wants to make some deal, of which no, they don't want other three companies not to be aware of it. Okay, in that case they can create a channel, so which is exposed, which is going to exclusive only two of this entities, like company one, company two, and they can do the transaction. So that's being facilitated by channels. And what is gossip protocol and why it is used? And if you come from this is something similar to what we have studied in the distributed systems. So gossip protocol basically manages discovery, whether the peer is discoverable, is available or not, and it is going to ensure the availability of data and ordering of data. So then what about the client application? So client application uses Fabric SDK. So Fabric SDK is provided by the tool when we download Hyperledger Fabric. So that is going to give us the SDK. So the Hyperledger Fabric itself is developed in a Go language, which is developed by Google, and also it has support for Java. So the moment we are going to take SDK, okay, so using that SDK provided APIs tools, we can define the client application. Okay, so what are we basically going to write? So this is what we will be trying to write. So we'll be querying, we'll be updating, we'll be just be trying to read. So what are the orders in which what is order in which the ordering service takes place? First within the Hyperledger Fabric network. So within this available network, so we are trying to form ordering service nodes. So using so first this has to be done. As example is given, like with the moment we download Hyperledger Fabric, there is a default file called order.yaml file, wherein all the for a given example use case, the different schemes are defined which can be used. Once we identify with ordering service, next we are going to identify start peer nodes. Okay, within that Fabric network, we are going to identify the peer nodes, and we'll be identifying the endorser node and the committer node. Then we'll be installing chain code. Chain code is nothing but software, because say for example, this is the transaction I'm interested, wherein four entities are participating. Right? This can be retailer. This can be the producer. This can be the bank. This can be the regulatory authority. Right? Let's assume. So the soft contract based on the mutual consensus among the all will have to be installed. Next stage is create channels. Now each and everyone wants to be communicating with the ordering service, or they want to perform the transaction, right? The channels will have to be created, and we'll have to join the channel. So how to create the channel? So there are commands, set of commands that will appear, channel create, and once that is done, then you have to be joining to the channels. Then instantiate code chain. So we have deployed it, then that is to be executed. So executed using chain code instantiate is the command which is going to drive that. Hope that we have seen this earlier, and quickly I'll go through that. So typically a blockchain looks like, it starts with a block, and each block has a header, and so here is a header, right? This is a header. This is the Genesis first block, and each of them is having data, and data is expressed in terms of number of transaction, and this is block metadata. Okay, so data about all this transaction, all this block is called as metadata. So this is stored. So this is our typical blockchain structure, internals of block structure look like, and this is absolutely immutable. Okay, if at all we have made any transaction, that is going to be appended, so not that is going to be tampered. That's a critical feature. I have repeated so many times, but the essence is the data should not be tampered. And if you just look at the block header, it is going to have a block number and current block hash. The block hash is the one. So hash is the algorithm using which we maintain integrity of the data. So the data is not tampered. So over a period of time, so using this hash is what we are going to prove the data. Okay, I hope that we all are familiar with what is hash, and often we use MD5 hash, right? Okay, so the moment that the source data is changed, so is the hash. So using the hash, we are going to validate or verify the data is changed or not changed. So let me quickly go through a concrete example, and okay. So before we see concrete example, let's try to have some general picture. Let's say that there are 4 different organizations, R1 to R4, have jointly decided a return into an agreement. Okay, and they're going to set up Hyperledger Fabric network. Okay, so out of this R1 to R4, R4 has been assigned the network initiator. What does it mean? So it has given the power to set up the initial version of the network. Okay, what is a network? Okay, who are all going to be participating in it? How are they going to be connected with each other? What are they being, what they will be doing? Okay, so that is what is a network, right? So when we say, when we have 10 different computers, they're just computers. When we are going to form a network, what does it mean? So we're going to connect them together. When we're going to define the protocol, we're going to put some switches, routers, and they're going to connect to the external world, to the internet, right? So R4, R4 is the network initiator that doesn't have any purpose of performing any business transaction in the network. Okay. So here are the few business requirements for this use case. R1 and R2 need to have private communication. Okay. R1 has a client application that can perform business transaction with channel C1, right? Where is channel C1? And the next thing is like R2 has a client application that can do similar work in channel and C2. So by just combining channel C1 and C2, channel C1 and C2 is just for R1 and R2. So these are all the business requirements which we are defining, and accordingly the network is configured. So likewise, we are just laying out the business requirements out of n number of available entities, how the network is to be formed, and who has to communicate with what, and everything is defined, and this channel is defined. So C1 is going to connect what are the entities. Then we define something called as CC. So CC is like the channel configuration. So this channel C1 now is connected via CC1. So CC1, so we have seen channel C1 and C2 is just for R1 and R2. Okay, so we are just now combining them together and we create CC1, and CC1 is now going to have R1 and R2. Okay, so don't get confused. So this is a network formation. So how are we going to define the network? That is purely based on the business context. So I'll quickly go through a use case. Say, for example, there is a customer who wants to order some red roses to the merchant. Okay, so this is a scenario. So how Hyperledger Fabric is going to be used for this kind of requirement. Right? So all are going to be taking coordinate, a customer and a merchant, peer 1 and peer A and B, and there is a customer and the transaction proposal, there is a SDK. So first thing is like endorsement policy. Okay, so the endorsement policy, this authorization must be accepted by all parties, and they should define a chain code, and using this SDK, this chain code is defined. Okay, so it is not going to be somebody is going to execute the code on this particular node. So we'll be just defining the chain code, and the chain code is going to be installed on the remote network Hyperledger, and that is going to get executed. The second phase is like endorsement of peers verification. So whether they are allowed to do or not. Okay, and so certain things to be verified is like the transaction in the past. And the third, the next stage is like execute it. Once the endorsement is set and the chain code is prepared and they are validated with the signing, and so they're going to be executed, and proposal responses are going to be inspected. Okay. So that's what. So if you just know, first we are going to propose transaction. So the client application is going to propose a transaction to E1 to E0 to E2. So E0 to E2, so they are all the participants are endorsers. So one second thing is like execute a protocol. I'm just trying to give a general picture. Third thing is like application receives some response. The next stage is like response is submitted for ordering. So we are just going to form this ordering service. The response received from the the endorsers are submitted to the ordering service, and the transaction is delivered. So wherever the data is maintained, so the transaction is delivered. So please try to visit this Raft. Raft is the algorithm, consensus algorithm, how it is going to work. So there is a visual simulation of how it is going to work out. And next is we are going to validate whether the transaction is completed successfully, so that the state of the data is updated or not. Okay, here the important feature that we will be validating is like it's not just in only one particular ledger the data is updated. So we want to ensure that all the affected ledgers are updated with the latest value. And finally, each of the peers, each of the committing peers, right, where the data is updated, sending notifications back to the client application. So that is how the transaction is defined. So now come to this concrete example. Now, so the customer wants to add some roses. We are going to identify. First, we will start with endorsement policy, identify endorsing peers, come up with chain code, and execute it, get response, and validate it, and convert endorsement into transaction, so that all the ledgers are going to be updated. And finally, there has to the ledgers are updated and the confirmation has to be sent back. So I think we are almost reached the time. So let me try to give some examples in the real world examples where it is being used. This I just taken from one of the papers being published recently. So this use case is specifically from typical e-governance application. See, a couple of use cases like land registry records. right? So we all know how we do land registration, right? We just have documents, and in spite of that, we come across news that there are some forgeries. Okay, somebody is owning a land, but someone else might claim that the property belongs to that person, right? So how it can be addressed, how different countries are making use of Hyperledger for different e-governance related use cases. Okay, so here for registering the land, I think there is a proposal in the government as well in India, right? How to make use of this blockchain or Hyperledger technology to convert all this land registration. So the land registration data is going to be, and now instead of sitting at one particular register's database, it is going to be decentralized, and all the transaction is going to be authenticated and validated. Somebody is going to say, for example, compromise some data. It is very hard to compromise all the data, right? Easily it can be validated, and so I believe that sooner in our country we may see so many implementations based on this blockchain Hyperledger fabric. And how it is getting mapped. So what are all the assets in the space of government? So asset can be anything, right? From so now not limited to cryptocurrency, it can be anything. So who all are the participating agencies with whom the smart contracts are established, and what entity from the government is managing that. So this particular example is from blockchain implementation or Hyperledger implementation, fabric implementation for Dubai government. This is from one of the recent projects that they have implemented. So these are the different roles. So this is a quick summary. One contrasting feature, Ethereum or blockchain is for financial transaction or for Bitcoin related, whereas Hyperledger fabric is a general purpose. And if at all we want to get started, what does it need? It basically you should know the architecture. You should understand the framework. Then programming languages like Go language or Java might help you to get started in defining developing the smart contract or chain code. And a bit of networking idea in the network would help. So with this, let me close my session here. I think it's time. So if you have any questions, maybe you can ask. So
yeah, I don't know. Vignesh sir.
Yes, because sir.
Sir, I am Arul.
Sir, so yes, sir.
Yes, sir. Okay, sir. Participants, you have any doubts? Please post. Sir, some of them they are posting 1 or 2 questions, sir. Sir, you opened the chat.
Yes, I have opened. Do you have some coding on Hyperledger fabric? Can you explain the question? Right now, I do not have any code because this session is only in one session. Packing the theoretical background and code might not work out. But what you can do is by just visiting the Hyperledger fabric website, all the codes are it is just a script. You have to download one particular script from the Git repo and you have to execute. What it is going to do, it is going to download a certain Docker images and Docker images, and it is going to run all the necessary components. So that way you can verify. It is not just a code; it has got many example use cases.
Hello, participants. You have any more doubts? Sir is in the line only.
So can we make a variant of BFTN plugin and test in Hyperledger? It should be doable. It should be doable. I don't have any light on that particular thing, but it should be doable as long as it aligns with the specification. Any trust-based technique are available to protect block. Here the basic idea is like every block or every transaction is going to be hashed, and we are going to maintain the hash of the previous transaction. That is how, so we maintain integrity of data. Okay, but whereas trust, here the trust is for the peer. Say for example, I want to be participating in the blockchain fabric network, right? But for that I should be defining, or I should be validating, or I should be proving who I am. Okay, so trust is for the peer level, but data integrity is just maintained. That's integral feature of the blockchain concept. So which consensus algorithm we use in Hyperledger? There are, as I told earlier, there are two major categories, probabilistic and deterministic. There are many deterministic algorithms available. So using deterministic, so probabilistic is used to be used when the data is huge and we are bothering about performance versus performance when we are about speed, then you just go for performance, but the accuracy may not be there. So it's probabilistic, right? Okay, that's why in case of streaming data applications, we use probabilistic based algorithm. But whereas in case of accuracy, since we are going to deal with financial domain and transaction, so you can't be probabilistic about a transaction. Okay, it can be between 1 and 0 and 1, so may not work out, right? So in that case, any suitable deterministic consensus algorithm can be used. Any source to study the plugin? I don't get the question. Coding language for smart contract in Hyperledger. There is a question on hands-on on our own. So the best place to get started is the official website itself. So as I told earlier, it's going to be a simple script. That script will, as I told earlier, will download all the required software like Docker and everything that's going to get download. So basically, what does it need is like you may be on a in a Windows machine. So what you need to have is like Linux environment, because most of the things work on Linux environment. So you should have Linux machine, something like Ubuntu, and on top of it you have to install certain prerequisites like curl and Python and Docker. Docker you should have installed, and Go language. Go language is the one. So once that is done, then script is going to do everything for you. So it has got certain use cases. By default, there are a couple of use cases that they have given. That use cases you can easily execute it. It is going to be just you have to execute some shell script or some JavaScript or some Node.js application. But I would say that if you find any use cases based on Node.js, you should be understanding how to work out, or how to be enabling the environment and running it. So it is better to have some idea on some programming language like Go or Java or JavaScript or Python. If you are familiar with any of these languages, to get started will be easier.
Vignesh sir?
Yes, sir.
Yes, sir. I think furthermore, no questions.
There's a question like probabilistic or deterministic algorithm. So there's a lot of literature available on it, like Bisonet and Shiv. Okay, and I think Bisonet is the one being majorly used in Hyperledger Fabric. Others also, other algorithms can also be investigated and used.
Participants, any more doubts? Shall we wind up? Okay, sir. Further, no more question. Vignesh sir,
Yes, sir. Yes, please.
thank you very much, sir. You start
Thank
our
you.
first program and successfully completed the last session. Okay, really, I'm very happy, sir.
Thank you. Thank you. Thank you for the opportunity, sir.
Thank you very much, sir. Thank you very much, sir. So,
Thank
participants,
you.
first we are ending our the technical session. So, afternoon our session will start 2 o'clock. So, then we'll post the Google form link and the chat box. Similarly, in the WhatsApp. So, 2 o'clock the session will start. 2:10 onwards our exam. So 2:10 to 2:40, 30 minutes exam. So already I sent the schedule of the afternoon session through WhatsApp as well as the mail also. So we'll follow as per the schedule only. So exactly 2 o'clock we'll post the exam link, the WhatsApp as well as the chat also. So please come exactly 2 o'clock. So 2:10 to 2:30 our exam. You want anything you want to clarify?
Hello.
Hello, tell me, sir.
Yes, sir. Like this exam will be on online, right? Like maybe
Yes, sir.
like on
Yes, sir. Online it is a Google form.
Google form. Acha, acha. So the link will be shared to emails or directly we can log in into this GoToMeeting portal.
No, yes, sir. You log in our meeting the session link only. You log in the session link. All the participants log in the given session link. The session chat box will post the exam link exactly to 2:10. Similarly, we will post the exam link the chat also, the WhatsApp also exactly 2:10. The link will
Yes,
open. The link will open 2:10 only.
got it, sir.
Sir,
Thank you very much.
Yes, sir.
can we have
Okay,
recorded
because
videos,
exam,
sir? If
what, sir?
possible, can we have if possible, can we have the recorded videos of all these sessions, sir?
Sir, recorded video already I mailed. What is the, we got the instruction from AICTE. They told to don't send the recorded video directly to the participants. You send to us. So they are planning to combine all the videos. They will upload in their portal. So that is the instruction
Okay, fine, sir.
that AICTE,
fine.
sir. Otherwise, for
Okay,
us,
sir.
no problem to share the videos to you. Okay.
Okay, sir.
Anything?
Thank you.
Okay. Thank you very much. We'll meet afternoon. Bye.